Hey everyone, ready for another deep dive. Today we're tackling large language models. You know, those AI tools that can code, translate, even write music.
Pretty incredible stuff, right?
Seriously impressive. But with all this power comes, well, a lot of responsibility, right?
Yeah.
We need to make sure these LLMs are used ethically and safely.
That's where responsible LLMs come in. It's all about making sure these AI systems are developed and used in a way that benefits everyone while minimizing risks.
So it's more than just like making sure the AI isn't offensive.
Oh, way more. We're talking data privacy, preventing the AI from making stuff up, and making sure it can't be manipulated for harmful purposes. These are some complex technical challenges.
Okay, so let's break it down. You gave me some research that outlines 4 key phases in the LLM lifecycle.
Yeah.
Can you walk us through those and how responsible AI fits in at each stage?
Absolutely. The first phase is data collection and pre-training. This is where the LLM learns language from huge data sets. We're talking billions of words from the web, books, code, and more.
Like feeding the LLM a balanced diet. You don't want it learning from biased or unreliable sources.
Perfect analogy. The data used to train an LLM shapes its entire worldview. So quality and diversity are super important for responsible AI. We got to carefully curate the data, filter out harmful content, and watch out for biases that could lead to unfair or discriminatory outputs.
Makes sense. What happens after the LLM is trained on all this data?
Then we move on to fine-tuning and alignment. This is where we tailor the LLM for specific tasks and make sure its values align with what we expect, like sending the LLM to specialized training.
So we're not just letting it loose with all that knowledge, guiding it to use its powers for good.
Exactly. Fine-tuning uses smaller, targeted data sets for the specific task, like writing marketing copy or translating languages. And importantly, we use techniques like reinforcement learning to teach the LLM to prioritize helpful, harmless, and honest outputs.
Wow, it's amazing how we can shape the LLM's behavior through training and fine-tuning. But how do we actually give it instructions? Talk to it.
Good question. That brings us to prompting and reasoning. The third phase, it's all about how we communicate with the LLM, asking questions, giving it instructions.
So even with a well-trained, well-aligned LLM, we can still mess things up by giving bad instructions.
Absolutely. Think of it like giving someone directions. If you're vague or unclear, they could get lost.
Right.
It's the same with LLM.
Okay, so clear communication is key.
Yep.
But even with careful prompting, isn't there still a chance the LLM could generate something problematic?
That's where the final phase comes in. Post-processing and auditing, our last line of defense. We carefully review the LLM's outputs before releasing them.
A quality control check, catching any errors or potential issues.
Exactly. This stage uses automated tools and human reviewers to evaluate responses for accuracy, fairness, and safety. Think bias detection, toxicity filtering, and factual verification to catch problems.
Sounds like a lot of work goes into making sure these LLMs are used responsibly.
It definitely is. Responsible AI needs a multifaceted approach. Careful consideration of data quality, alignment with our values, thoughtful prompting, and rigorous post-processing. And we're just getting started, always developing new and better methods.
So we've got a good overview of the LLM lifecycle and what responsible AI means at each stage. Let's get into some specific risks and challenges. This research paper highlights how LLMs can leak private information. Kind of unsettling.
Definitely a valid concern.
Yeah.
People often think about privacy in terms of LLMs memorizing and repeating sensitive info, but it's more than that. These models are great at spotting patterns and making inferences, and that can lead to leaks.
Inferences? Like how?
Imagine an LLM trained on social media posts, purchase history, location data. It might not memorize someone's address directly.
Right.
But if you ask about their vacation photos, it could figure out their address by connecting the dots.
Whoa, that's kind of scary.
Yeah.
Like piecing together a puzzle with seemingly harmless info? Aren't there safeguards to prevent that?
There are, but it's a constant back and forth. Developers create privacy-preserving techniques, and others try to exploit the system. This research talks about some attack vectors, like membership inference attacks, data extraction attacks, and prompt inversion attacks. Understanding those is crucial for building strong defenses.
Okay, let's explore those attack vectors and what researchers are doing to counter them. This is where it gets really interesting. So membership inference attacks, what are those?
Well, imagine you wrote like a super embarrassing blog post years ago.
Oh no, don't even say it. I can only imagine the cringe.
And now you're worried it might be part of an LLM's training data. In a membership inference attack, someone tries to figure out if a specific piece of data, like your blog post, was used to train the model.
Okay, that makes sense. But how could they actually figure that out?
It's all about those tiny differences in the LLM's responses. By crafting prompts and analyzing what the LLM spits out, an attacker can spot these subtle changes, like variations in the LLM's confidence or how smoothly it generates text, depending on whether it's seen that data before.
So if the LLM gets all awkward and stumbles over words when talking about my embarrassing blog post, that's a bad sign.
Yep, pretty much.
Yeah.
Like recognizing someone's voice even if they're trying to change it.
Oh, that's creepy. Okay, so what about data extraction attacks? How do those work?
Data extraction attacks are even more direct. The goal is to actually pull out pieces of the training data from the LLM's output. Imagine recovering entire sentences or even paragraphs from the massive data set it was trained on.
Whoa, that sounds like a major security breach. How's that even possible?
It comes down to how LLMs learn and store information. They don't just memorize things word for word. They create these compressed representations of patterns. But sometimes those representations can be decoded to reveal parts of the original data.
So it's like a digital archaeologist digging through the LLM's memory.
Perfect analogy. The research we're looking at goes into some really clever ways to do that, using specific prompts, statistical analysis, and even adversarial training to get the LLM to spill the beans, so to speak.
Okay, this is getting a bit freaky. You mentioned a third type of attack, prompt inversion attacks. What are those all about?
Prompt inversion attacks target the private data used as examples in context learning.
In context learning.
Right. It's how we teach LLMs new things by giving them examples, like showing a kid how to tie their shoes a few times.
Got it. So we're using examples to guide the LLM. But how can those be a problem?
Let's say you're using in-context learning to teach an LLM how to, I don't know, redact sensitive info from documents. You give it real examples, but with the sensitive stuff blocked out. A prompt inversion attack could reverse engineer those examples and uncover the original unredacted data.
So basically using the LLM's learning process against it. That's sneaky.
It is. It's a clever exploitation of in-context learning, and this research shows some surprisingly effective ways to do it.
It sounds like those working on responsible AI have a tough job, but surely they're coming up with ways to fight back against these privacy attacks, right?
No, absolutely. Lots of exciting work happening. One approach is data sanitization, cleaning up the training data before the LLM ever sees it.
So scrubbing out personal info before it goes into the LLM's training, like names, addresses, phone numbers.
More than that, techniques like differential privacy add carefully calculated noise to the data, making it harder to extract individual data points while preserving the overall statistics.
So a bit of strategic fuzziness to protect the data. Makes sense. What else?
Researchers are also working on privacy-preserving in-context learning methods, using cryptography and clever algorithms to protect the examples we use during training.
It's amazing how they're coming up with these technical solutions for such a complex problem.
For sure. It really highlights why ongoing research and collaboration are so important in responsible AI. We need to stay one step ahead, predicting new attacks and building strong defenses.
Okay, so we've gone deep on data privacy. Time to switch gears and talk about another big issue with LLMs. Hallucinations. You mentioned they can sometimes make stuff up.
Yeah.
Even when they're well-trained.
Right. Hallucinations, another area where technical solutions are super important.
Definitely. But before we get into the solutions, why do LLMs hallucinate in the first place? Is it like a bug that needs fixing, or is it something deeper?
It's more than a simple bug. The causes are still being studied, but this research points to a few key factors. One is the nature of the transformer architecture itself.
The what now?
Oh, sorry, the transformer architecture. It's the underlying neural network structure that powers most of the top LLMs today. It uses something called self-attention.
Self-attention.
Basically, it lets the model weigh the importance of different words in a sentence when it's generating text.
So it's paying attention to the context, figuring out which words matter most.
Right. But this self-attention, while powerful, can sometimes cause what researchers call attention glitches. That's when the model gets too focused on certain words or phrases and misses the big picture, leading to outputs that don't make sense or are just plain wrong.
Like getting lost in the details and forgetting what you were reading about in the first place.
Exactly. And these glitches can be made worse by things like bad training data, misalignment with human values, and problems with how the LLM decodes information.
So it's a multifaceted problem.
It is.
But I'm sure researchers are working on ways to reduce these hallucinations, right?
Oh, absolutely. Lots of promising approaches being explored. One is developing new decoding methods that contrast different layers of the LLM.
Different layers.
Think of an LLM as a building with many floors, each floor processing information at a different level. Lower floors focus on words and grammar, while higher floors are all about meaning and semantics. By comparing outputs from different floors, we get a more complete picture, reducing the chance of those attention glitches.
So it's like getting a second opinion from someone more experienced, making sure everyone's on the same page.
Exactly. Another promising technique is retrieval augmented generation. This gives the LLM access to external knowledge bases and search engines so it can fact-check itself in real time.
So if the LLM is unsure, it can just Google it.
Yep. That can drastically reduce hallucinations, especially with facts and claims that need external verification. Researchers are also working on advanced prompting techniques to steer the LLM's reasoning process, encouraging it to look at the bigger picture.
So by asking the right questions and structuring the input carefully, we can help the LLM stay on track and produce more accurate outputs.
Exactly. It's all about knowing the LLM's strengths and weaknesses and using them to our advantage.
This is all so fascinating. Every challenge seems to lead to even more creative solutions and a deeper understanding of how these LLMs work.
It really shows how innovative the researchers in this field are, constantly pushing the boundaries, figuring out the risks, and coming up with smart solutions.
Okay, we've covered data privacy and hallucinations. This research also mentions jailbreaking LLMs, which sounds a little scary. What exactly does that mean, and what does it have to do with responsible AI?
Ah, yes, jailbreaking. That takes us into the realm of potential misuse and manipulation. Essentially, it's tricking an LLM into bypassing its safety measures and doing something harmful or unethical.
Wait, so even if an LLM is supposed to be helpful and harmless, someone could manipulate it to do bad things, like hacking, but with words.
You got it. And it's a serious issue that researchers are looking into. Let's dive into some of the methods used to jailbreak LLMs and what's being done to prevent this kind of malicious exploitation.
Okay, so how do these jailbreaks work? Like, what are some of the techniques attackers might use?
One way is by injecting backdoors into the training data, basically sneaking in these subtle manipulations that create hidden triggers for the LLM.
Hidden triggers, like a secret code that makes the LLM do something bad.
You got it. They can be words, phrases, even formatting patterns that blend in with all the other data. But when the attacker uses those triggers, boom, the LLM goes off script.
That's so sneaky. What else can they do?
Another trick is fine-tuning with malicious data sets. So you take an LLM that's already trained and then train it further on a smaller data set, but this time the data is designed to teach it harmful behaviors.
So instead of learning to be good, it's learning to be bad.
Pretty much. And this can be really effective because fine-tuning can overwrite the LLM's original safety programming with malicious goals.
That's scary. So we need to be super careful about the data used for fine-tuning.
Absolutely. Knowing where the data came from and making sure it's not been messed with is so important.
Okay, so we've got backdoors and malicious fine-tuning. Anything else?
Well, there's also adversarial prompting. This is more like a verbal trick. It's about finding those loopholes in the LLM's logic and exploiting them.
So, like, instead of sneaking in bad code or data, they use clever wording to get the LLM to do something harmful?
Exactly. LLMs want to be helpful and engaging, but they don't always understand the nuances of human values and ethics. So a skilled attacker could write a prompt that seems harmless, but actually leads the LLM down a dangerous path.
Wow, so you could ask it something seemingly innocent, and it could end up saying something terrible.
Yep. And because these adversarial prompts are so context-specific, they can be really hard to detect and defend against.
Okay, this is all starting to sound pretty overwhelming, but I'm hoping researchers are figuring out ways to defend against these jailbreak attacks.
Don't worry, they are. It's like an arms race. For every attack, there's a defense being developed. One area is rigorous data filtering, using fancy algorithms to scan the data and weed out any of those backdoor triggers or other malicious patterns.
Like an antivirus for LLMs.
Exactly. Catching those problems early is key.
Makes sense. And what about malicious fine-tuning? How do we stop that?
Well, we need better fine-tuning methods that focus on both safety and utility. It's about making sure the LLM can still learn new stuff, but without compromising its original safety programming.
So, making sure the LLM can learn new tricks without forgetting its manners.
You got it.
And what about those tricky adversarial prompts? Any way to protect against those?
One way is to use prompting strategies that, really hammer home those ethical boundaries, like crafting prompts that explicitly state the desired values and limits, basically guiding the LLM towards making ethical choices.
So giving it a moral compass.
Exactly. By baking ethics into the prompting process, we can steer the LLM in the right direction, even when faced with sneaky manipulation attempts.
It's amazing how much effort is going into making these LLMs safer and more reliable.
It really shows how important responsible AI development is becoming. As this technology gets more powerful and more common, we absolutely have to prioritize safety, fairness, and ethics right from the start.
Well, this deep dive has been a wild ride. We've covered so much about responsible LLMs, data privacy, hallucinations, even those scary jailbreak attacks, and of course, all the incredible work being done to keep these systems in check. It's clear that this field is moving fast, and the future of AI depends on getting this right.
I couldn't agree more. And the coolest thing is, we're just getting started. As LLMs become even more capable, we'll uncover new challenges and opportunities, driving even more innovation in responsible AI.
So we end this deep dive with a mix of excitement and, I guess, caution. Excited about the potential of these technologies, but also cautious about using them responsibly. It's on all of us to make sure these powerful tools are used for good and benefit everyone.
Well said. It's a shared responsibility for sure. Researchers, developers, policymakers, everyone needs to be part of the conversation. As we venture into this new territory, we need that sense of wonder, but also a healthy dose of critical thinking.
That's a great way to put it. Thanks for joining us on this deep dive into responsible LLMs. We hope you found it as fascinating as we did. Until next time, keep learning, keep exploring, and keep asking the tough questions.